Good morning, everybody. So let's go ahead and graph some quadratic functions. This first example, it's called a warm-up from a previous lesson, but this first quadratic function looks like this. And this function predicts the height of a dropped object from the top of a 300-foot tall building. So think of something that's almost 30 stories tall, and you reach over the edge and drop maybe a tennis ball off of the side. This will represent how high up off the ground that tennis ball is for t, which is time. And underneath here, what I've done is I've just chosen some kind of various seconds after the drop. For each one of these, I'm just putting a number in the t spot. You'll normally have something like y equals with an x, and it may or may not have a number after it. If it has a number after it, by the way, this thing right here, this is your y-intercept. That'll be something to keep in mind. With that in mind, we have 0 and 300, 1 and 284, 2 and 236, 3 and 156. You can see the calculation there and so on. The objective here is that you simply observe that if you have a quadratic function, you can set up a table of values choosing the basic numbers like 0, 1, 2, and 3, and you can substitute those in and you can find out using your calculator or, well, not calculator, you could figure out what those number values are going to equal. Now, with that in mind, let's go ahead and talk about, we're going to skip some of these things in purple here because it's going to make the video and the lesson a little bit longer than we want. Something that you may want to consider, Desmos. Man, Desmos is such a great app. If you open up the Desmos app and click on the hamburger stack and then choose Parabola's standard form from the drop-down menu, what you'll get is a parabola that looks like this one with a slider that you can move left and right and sliders for all the values of A, B, and C, right? This thing right here, this is the generic form or what we call the standard form of a quadratic equation or something that makes a parabola. The only ones we really want to focus on for today would be these two, the A value and the C value. So you may want to consider opening up Desmos, clicking on the hamburger stack, choosing Parabola's standard form, and sliding the A value left to make it negative or right to make it positive. Sorry, there's left and right. Or moving the C value left or right to see how that changes your graph. That's going to give you some information as to what your graphs should look like. All right, you can do that as long as you feel like you need to. It's a fun little activity for a minute or two. And then in theory, you could answer all of these purple questions. What happens when A is greater than 0? What happens when A is less than 0? What happens when A equals 0? And what would happen if the C value changes up or down or stays at 0? So with that in mind, let's go ahead and move on to the stuff that I have in blue. Now, let's go ahead and do some graphing. What I've done in each one of these is I've set up a table of values. That's over here. And I've given you an equation. That's here. And I've given you a graph. Now, unfortunately, my Notability files don't let you see the grid. So I've taken the grid away on my option as well. And I've given you something to kind of keep in mind over here as well. If you watch the the vocabulary video in Edpuzzle, you saw vertex, mins and maxes, and the axis of symmetry all referenced in that really good video. So here's what I want you to see. If this very first one is called the parent graph, which it is, y equals x squared, right? Y equals x squared is the most basic quadratic function that exists. We're going to call that the parent graph, and everything else is based upon that parent. Then here's what we're going to do. If x equals 0, I'm looking at the very first one. If x equals 0, then y equals 0 squared, or 0. And if x equals 1, then y equals 1 squared. Or if x is 2, y equals 2 squared. Or if x equals 3, y equals 3 squared. And you see these pairs of numbers, 0, 0, and 1, 1, and 2, 4 is, I'm going to move it this time. So 2, 4. I'm going to have to do some estimating here, right? Do the best that you can. And then I'm going to do one more of those to do 3 and 9. So 3 and 9 is, I know this isn't perfect, but it's going to be up here somewhere about right there. Now, something that you should keep in mind, each one of these have an axis of symmetry. And that axis of symmetry for every one we're going to do today, the axis of symmetry is right there. where x is 0. For each one of these, x is 0 is the axis of symmetry. And what that tells me is, I'm going to zoom way in, what that tells me is if you have a dot that is this far away from the axis of symmetry on the right side, then you're going to have a dot that many spaces away from the axis of symmetry on the other side. And I can get rid of all of this stuff here. I accidentally erased the 1, so let's put that back in there. And you could do the same thing here, right? This one is 2 spaces away from the axis of symmetry, so you can imagine moving over 2 spaces this way. And you can imagine doing the same thing. Once again, I'll move the bouncing dot. So 1, 2, 3 spaces. So 1, 2, 3 spaces should be about right here. I didn't have to add those to my table of values. I just have to know about the axis of symmetry. And then in one, hopefully smooth line that's curvy with arrows on the top, left and right side, you have yourself your first parabola. The vertex in this case is a minimum, right? Your vertex is right here, so it's a minimum because it's at the bottom, and the vertex is at 0, 0. So it's easy to fill in all 3 of the items here. Now, I'm not going to do every one of these in the video. What I am going to do is just a snippet of them. The ones that are highlighted and circled I'm going to do. So let's jump down to number 3. Once again, I'm setting up the table of values for you. X is 0, so I'm going to do y equals a half of 0 squared. Well, 0 squared is 0, and 0 times a half is 0, so we still have that. Now I put a 2 in there. I have 1/2 of 2 squared. Well, 2 squared is 4, and half of that is 2. And y equals half of 4 squared. So 4 squared is 4 squared is 16, and cut in half is 8. So here we go. 0, 0, 2, 2, and 4, 8. Let's see, 4, I'm coming up from 4, I'm coming over from 8. This is another way to do it, and then just grab the eraser tool and clean it up that way. I could go ahead and identify with a dashed line this time my axis of symmetry. My axis of symmetry is going to be x is 0. I recognize that each one of these, let's see, 1, 2, so 1, 2, boom, and 1, 2, 3, 4. So 1, 2, 3, 4. I'm going to have my symmetry help me with all of my points. I realize that my vertex is once again at 0, 0, and because it's at the bottom, it's a minimum. Once again, nice smooth curve. The curve will be most represented down here at the bottom. Try to avoid a V shape. It'll look a little bit more like a U instead of a V. Maybe if it's upside down, maybe it looks like an umbrella instead of an arrow. I'm going to move down to number 5. This one is the first one. Now, if you've played around with Desmos, you might recognize that that thing being negative means it's going to open downwards. Means it's going to look more like an umbrella than it did like a cereal bowl on the ones above. Watch this. So 0, y equals negative 0 squared is negative 0. That doesn't make any sense, so just 0. Y equals negative 1 squared is negative 1. Negative 2 squared is negative 4. And negative 3 squared is negative 9. Now this one's going to be a little different. So 0, 0 is right here. I'll make the dots again. So positive 1, negative 1. So positive 1, negative 1 is right here. And while I'm at it, I'm going to go ahead and make the symmetric version as well. And now I'm going to do 2, negative 4. So 2, negative 4 is about like this. And 1, 2 spaces to the axis of symmetry. So 1, 2 spaces over. If I had a grid, this would be much more accurate. And then this last one's going to go a little bit off the grid here. I don't have a negative 9, but I bet I could make a pretty good guess. 3 and negative 9 is probably about right there. And the symmetric version would be about right here. Once again, this is more of a sketch than anything. I'll try to make that curve. Mine doesn't look great, but I think that'll get the job done. My vertex is still 0, 0. This time it's a maximum, and the axis of symmetry hasn't really changed at all today. It is still right through x equals 0, so it stays x equals 0. Now, I have a number of other ones on here that I was considering trying. It's going to make this video really, really lengthy. So let's pick number 10. right? So even though I thought you would do some of these with me, you'd probably rather do them on your own instead of watching a video with me doing them. So here we go. Last one, it looks like I guess I have these answers in. So if you're really observant, you can just pause and go back and fill them in. But let's go ahead and roll with this. If x is -2, now notice I'm going ahead and choosing the values right here. What I'm going to do, because it has treated me nicely so far, is choose a 0 to start with. So y is -4 times 0 squared plus 5. So 0 squared is 0 times -4 is 0 plus 5 is 5. Now I'm going to try that same thing with a 1. And 1 squared is 1 times -4 is -4. -4 plus 5 is +1. And I'm going to do the same thing with the 2. And 2 squared is 4 times -4 is -16. Plus 5 is -11. So that's going to be pretty tough to fit on here. What I like about this, though, is because the axis of symmetry on this whole day is still x equals 0. That's this line right here. I'm going to go ahead and graph the three things that I observed so far. So 0, 5, right? I'm graphing 0, 5. So 0, 5 is right here. That is, by the way, our vertex. And let's see what happens now. 1, 1. So 1, 1 is right here. And I can go ahead and make my symmetry. So one space to the axis of symmetry, so one space on the other side. And already I can see that my vertex is going to be a maximum because it's going to be at the top. And everything's going to open downwards like an umbrella. So let's go ahead and do one more. Let's see. 2, -11. So 2, I got -8. That's -9, -10, -11. We're going to cheat a little bit and just kind of go down there. And then we're going to try to extend that over 1, 2. So 1, 2 is probably over here somewhere. And this one's really, oops, sometimes you miss. This one's going to be hard to have it not look like an arrow at the top. Just do what you can right up here. It's supposed to be a curve. If it ends up looking pointy, there's not much we can do about that. I don't really need that line anymore. And here's what I've observed, right? Even though I only calculated these three, because of symmetry, whatever 1 equals, -1 equals. So since +1 equaled +1, -1 equals +1. And since 2 equals -11, -2 equals -11. So I don't even really have to calculate those. I can, but I don't need to, because everything on one side of the line of symmetry is going to be the same as everything on the other side of the line of symmetry. So you only have to do half the work. Let's keep this video short. There are 11 questions total that I want you to graph. 1, 2, 3, 4 of them we've already done, so that means you have 7 more to go. You can see that they're not going to be that difficult. It should take a few minutes each, and that is that. So good luck today graphing quadratics.